So, starting with the name of the God, students, as we discussed in the previous lecture, that vector quantity is a quantity that needs magnitude and direction both to define that thing. For example, displacement was a vector quantity because it needs magnitude and direction both to define it. And we also came to know that how to find out the magnitude of a vector. This is the formula by which we can find out the magnitude of any vector. Because a vector actually contains two parts, x part and y part. X part is the length of its length along the x-axis, and y is its length along y-axis. So that's how we can find out the magnitude of any vector. We also discussed about equal vectors. Equal vectors are those vectors which are vectors having the same direction and magnitude as well. So both things should be same. The magnitude and direction should be same for two vectors to be equal. These both vectors have the same direction and same magnitude. And you also came to know that what is column vector. How can we find out the vectors column vector? We have to, I discussed it in the previous lecture in detail, that how one can find out the column vector. You have to, this is our point where we start counting. We will count the x boxes. X boxes are 3 and they are direction, the direction of the x-axis is towards left, so that's why 3 should be negative, and our y-axis direction is downward, 1 2 3 4, so y should also be negative. So this is -3 and -4 sorry, +3 and -4, y +3, because it is in the right side. So x-axis is on the right side. If x-axis is on the left, then it should be negative. Now the x-axis, x vector is on the right and this vector is on the left, downwards. That's why. How can we can also resolve a vector into its component. These two things are the component of this vector. This component, actually a vector is, if you know the head to tail rule, a vector components are actually, vector is sum of these two of its components. For example, you have a vector here. This is a vector which is called f. It has two components, fx and fy. So if you know head to tail rule, then you came to know that this f is actually sum or addition. This is actually addition. These two vectors are adding by head to tail rule, and this is the sum of these two vectors. So the components are actually adding up to and making this vector. So if the x component is towards right side, then it should be positive. If the x component is on the left side, it should be negative, and y component is if upwards it is positive, and here we will see that if we resolve a vector into its component, for example, this is a vector f, it has two components, this is fx, this is fy. So fx is positive because its direction is towards right, and fy is also positive because its direction is upwards. But if we have vector like this, if we resolve this into its component, it is a v vector and its component is vx and vy. So vx is negative. Why? Because it is left, its direction is towards left, and vy is positive because it is upward. We look another vector like this is a vector k, so it has two components, ky and kx. Kx is positive because it is towards right, and ky is negative because it is downwards. So we came on a conclusion that if the y component is downwards, then it is negative, and if the y component is upward, it is positive. If the x component is towards right, it is positive, and if the x component is towards left, it is negative. So if we have to draw this vector, for example, this is a vector, we have to draw this vector -4 -1. So how can we draw it? We can draw it simply. If we have to draw it here, we have to draw it here. How can we draw it? If a vector, for example, is -4 and -1 -2, for example, how we can draw it here? If the starting point is this one, then -4 is x-axis and means it is towards left, not right. So towards x-axis direction is towards left, and y is downward, so it is 2 point downward and 4 point left. 1 2 3 4 1 2 3. This is the vector, 2 points downward and 4 point left. So that's why it is -4 and -2. This is, for example, y vector, so this is y vector. Hope you people understand this concept, and you can draw any vector if you got this idea that how can we draw it. If you don't understand anything, you can also ask me in comments. I will make the lecture on that video, on that issue. So and we know about the that how can we find out the magnitude of two vectors. This is 3 and 4, and we can find out the magnitude of these two vectors. 3 squares minus 4 square is equal to 25. 5 square, I can this formula, you know about this. This is the formula to find out the magnitude of any vector, so we are applying this here. So there is an example that we have in this book, that the column vectors A and B are defined by A is equal to this minus 10p for q and B is equal to p plus 2. We have to find out the A and B. Find out the value of vector A and vector B. There are three ways to write a vector magnitude. You can write a vector magnitude by this or by a bold letter. So this is only magnitude. This is only magnitude of a vector because it is in the bold letter. So find out the value of P and Q. Number 1, given that A and B are equal, find out the value of P and Q. So these two are equal vectors, so this thing 10 minus P should be equal to P plus 2. So 10 minus P is equal to P plus 2. So we can easily find out this, and these two are equal, so we can find out this. So that the magnitude of both is this. So this is also very easy. If you find out the P and Q, then you can put this, by putting this value into this, you can find out the value of A and B, and both by putting this here and here, P and Q, you can find that this is 6 and this is 1/2. So if you find out the magnitude of these vectors, the magnitude should be this. And in the third part, you have to find out that express in terms of P and Q, this one. So you will put this here, x, not put the value of this x, instead of put this whole variable instead of x, put this whole variable instead of y, and then compare these two values and this. So I hope that you understand this example, students.